This is Algebra 1 class. Today we're going to look at factoring and solving trinomial equations. It's section 9.5 in your text. When factoring a trinomial back to two binomials, we need to look at how the trinomial was formed in the first place. So let's multiply the two binomials that I've written down here. And when we do that, we have first, which is x squared, outer, x times 3 is 3x, inner, 4 times x is 4x, and last 4 times 3 is 12. Notice that there are two like terms that are added together to make this middle term of 7x. So to reverse this process, we're going to use a type of guess and check. We're going to look at factors of the constant term. That's our last term, the factors of 12. And then we're going to see which factors add up to the linear term of 7x. So as I look at this particular trinomial, the factors of 12 would be 1 and 12, 2 and 6, and 3 and 4. Now, which factors add up to the linear term of 7x? That would be 3 and 4. So our original binomials then are going to be x plus 3 and x plus 4. And that's what we had to start with. So let's try some examples. Our instructions are to factor the trinomial. So our first step is going to be list the factors of the constant term. Our constant term is 21. And our factors are 1 and 21 and 3 and 7. Then I want to check to see which of these factors add up to the linear term. So which of these factors add up to 10 or 10x? Well, 1 plus 21 is 21, and that doesn't work. 3 plus 7 is 10. That one works. So these are the two factors that I want to use to multiply to get 21. This then forms the two binomials. Our first terms to get x squared would be x times x. Our last term to get 21, 3 times 7. Those are both addition. And so these are the two binomials that multiply to get x squared plus 10x plus 21. Let's check and see how that works. Here's our check. We're going to do first, x times x is x squared. Outer, x times 7 is 7x. Inner, 3 times x is 3x. And then last, 3 times 7 is 21. Notice that our outer and inner terms add to 10x as required. Let's do another one. Let's look at x squared plus 6x plus 5. Our factors of 5 are just 1 and 5. Do they add to 6 in the middle? 1 plus 5 equal to 6. They do. So these are the two terms that I want to use to multiply to get my last term in my trinomial. So our two binomials, our first term has to multiply to x squared, so x times x. Our last term has to multiply to 5, and we decided that the factors 1 and 5 work, so we have plus 1 and plus 5. Let's do a check. First, x times x is x squared. Outer, x times 5 is 5x. Inner, 1 times x is 1x, and last, 1 times 5 is 5. So x squared, adding these two terms together, gives us 6x plus 5. We have the trinomial that we want, x squared plus 6x plus 5. Okay, now let's see what happens if we have some negatives involved in it. We're going to start it the same way. We're going to list the factors of the constant term. This time the constant term is negative 10. So our factors to get negative 10 would be negative 1 and 10, 1 and negative 10. negative 2 and 5, and 2 and negative 5. We're looking for now a pair to add up to my linear term of negative 3x. So as I look at these pairs of factors, this pair is the one, when I add these two together, I get negative 3x. So the factors that I want to use to multiply to my last term are going to be 2 and negative 5. Let's write our two binomials. To get x squared is x times x. To get negative 10, we want to use 2 and negative 5, so plus 2 minus 5. Notice that one factor is positive, one factor is negative whenever our last term is negative. Let's do a quick check. First, x times x is x squared. Outer, x times negative 5 is negative 5x. Inner, 2 times x is 2x. And last, 2 times negative 5 is negative 10. And that gives us x squared minus 3x minus 10 as required. So this is our factored form. Each case, our factored form. Another way that we can look at it, it's still another way of looking at it with guess and check, but we're going to use a frame to help organize while we're looking at it. What we want to do in our frame is we're going to take our first term, x squared, and we're going to put it at the top of the frame, and our last term, negative 16, next to it. Below x squared, we want to write down how to multiply to get x squared. So this would be x and x. For our next part, it's best to use a pencil because you might end up erasing because we're going to do some guess and check. So we're going to look here at ways to multiply to get negative 16. Okay, so again, let's take a look at our factors of negative 16. I'm just going to write them over here on the side. Our factors of negative 16 are going to be negative 1 and 16, 1 and negative 16, negative 2 and 8, 2 and negative 8, and 4 and negative 4. Doesn't matter which one of these is negative. So when I'm working with this, I'm going to take the numbers that I put in these two boxes to multiply to negative 16, and I'm going to multiply them here. And then I'm going to add them to my middle term of negative 6x. My goal here is to get negative 6. So as I look at ways to multiply to get negative 16, I'm looking at this pair of 2 and negative 8, 2 and negative 8. X times 2 is 2x. X times negative 8 is negative 8x, and these two add up to negative 6x. So we've got the factors that we want, and our binomials go diagonally this way. So this becomes x minus 8 times x plus 2. First is x squared. Here's our check. First is x squared. Outer is 2x, inner is negative 8x, and last is negative 16. Our outer and inner term add to negative 6x as required, and so that's our factors. If you don't get the first pair right, then just guess again and try another possibility. Let's try these using a frame. So here we're using the variable y squared instead of x. It's okay, we can do that. We have y squared, which is y times y. And our goal is our middle term here of negative 5y. We want to take y multiplied by one of the factors of negative 14, again here, and add them to get negative 5y. So the factors of negative 14, Well, we have factors of negative 14. Again, negative 1 and 14, 1 and negative 14, negative 2 and 7, and 2 and negative 7. And our goal is to add to negative 5. So if I look at that pair, I see 2 and negative 7. Y times 2 is 2y. Y times negative 7 is negative 7y. These two add to negative 5. So here are two binomial factors, y plus 2 and y minus 7. Let's do that again. M squared and 15, our first term, our last term, and our goal to get a middle term of 8m. M squared is m times m. Factors of 15 that add to 8, well, we have 1 and 15 and 3 and 5. 3 and 5 add to 8. So m times 3 is 3m. M times 5 is 5m. Those add to 8. So our two factors going this way, m plus 5 and m plus 3. Let's do another one. Here we have factors of negative 70. Wow, those are going to be quite a few. So let's see what that looks like. Again, our first term is x squared. Our last term is negative 70. And our goal is the middle term of 3x. To multiply to get x squared, we have x times x. And now we need to multiply to get negative 70. There are a lot of factors that multiply to negative 70. So the factors of negative 70, I'm just going to write them up at the top of the screen here or on top of the problem. We have, of course, negative 1 and 70 and 1 and negative 70. 2 divides into that 35 times. And as we go through, 3 does not divide it, 4 does not divide it, but 5 does. So we have negative 5 and 14. 6 doesn't divide it, but 7 does. So we have negative 7 and 10, and 7 and negative 10, and 8 and 9 don't. So here's our whole list of ways to multiply to get negative 70. Let's see which ones I need to combine to get 3. As I look at all of those, I'm looking at the sums. Which pair adds to 3? Well, right here, negative 7 and 10 add to 3. So we have negative 7 and 10. Our check, x times negative 7, negative 7x, x times 10 is 10x. Those add to give us 3x. So our two binomials are here and here. X plus 10 times x minus 7. We can use factoring to solve a quadratic equation, just like we did in our previous lesson. All we need to do is get one side equal to 0, then factor the resulting trinomial and set each factor equal to 0. So number 7, we already have one side equal to 0, so let's factor this trinomial. I'm going to factor it by just writing down the two binomials. I know I'm going to have two binomials. And I'm going to look at factors of negative 12 that add to 4. So let's just list real quick the factors of negative 12. We have negative 1 and 12, 1 and negative 12, negative 2 and 6, 2 and negative 6, negative 3 and 4, and 3 and negative 4. I'm looking for a pair that add up to my middle term of 4x. So as I go through, I see this pair of factors adds up to 4. So to get x squared, we have x times x. To multiply to get negative 12, we've chosen the factors negative 2 and 6. So minus 2 plus 6. Again, a quick check to see if it works. First, x squared. Outer and inner, 6x and negative 2x add to 4x. And last, negative 2 times 6 is negative 12. So now let's set each factor equal to 0 using our zero product rule. So our factor x minus 2 could be 0. Solving gives us x equals 2. Or the factor x plus 6 can equal to 0. Solving gives us x equals negative 6, and we have two solutions. Let's do that again. One side is equal to 0, so we're going to factor this trinomial into two binomials. For m squared, we know our first term, m squared, has to be m times m. Our last term, 27, and we have a couple of ways that we can multiply to get positive 27. But notice my goal here is to add up to a negative number. So this time when I'm looking at the factors of 27, I'm only going to list the negative factors of 27. For instance, well, let's list them all and see how we can get it. We can have 1 and 27. We can have negative 1 and negative 27. We could have 3 and 9 and negative 3 and negative 9. Which pair of factors adds up to give me negative 12? Notice that I'm going to have to choose negative factors. So forget the positive pairs, only negative ones to add up to negative 12. This pair adds up to negative 12. So our two factors to multiply to get our last term of positive 27 are negative 3 and negative 9. And each one now is equal to 0. So using our zero product rule, our factor m minus 3 is equal to 0, giving us m equal to 3. Or our m minus 9 is equal to 0, giving us the solution m equals 9. And again, we have two solutions. Another example. This one is more just vocabulary. Here we go. Vocabulary. It says to find the zeros of a function, we set the function value equal to 0. So our function is f of x. We're going to set f of x equal to 0. So we have x squared minus 4x plus 3 equals 0. All I did was put the f of x as 0. Now we're going to factor it just like we did before. We have a trinomial, so let's break it up into two binomials. X squared is x times x. Our last term is 3. Our factors of 3 would be 1 and 3 or negative 1 and negative 3. We're looking for the pair that adds up to negative 4. So that's the one with two negative factors, minus 1 and minus 3. Set each factor equal to 0. So our factor x minus 1 equals 0, so x is 1. Or x minus 3 is equal to 0, so x is 3. And we have, again, two solutions, x equals 1 or x equals 3. Let's look at a story problem now. We're almost done. Write, excuse me, write and solve a quadratic equation to solve the following problem. You are designing a flag for the school football team with the dimensions shown in the diagram. The shaded region will show the team name. The flag itself requires 117 square inches of fabric. Find the width of the flag. So I'm looking for the width of the flag, which is W. The shaded region is 2 inches wide, and the unshaded region is W plus 2. And I know the total area, because we have square inches, that's area. My total area of the shaded and unshaded parts is 117 square inches. So to find the area of a rectangle, the area of a rectangle is the base multiplied by the height. The base is this entire distance all the way across, which is a distance of 2 plus W plus 2. That adds up to W plus 4. And our height is W. So the area, which we know is 117, is equal to our base, which is W plus 4, and our height, which is W. We want to solve this equation. We want to get one side of this equation equal to 0, and we want to have this as a trinomial. So let's start by distributing on our right side. We're going to take w times w to get w squared, and w times 4 to get 4w. Now let's get one side equal to 0 by subtracting 117 from both sides. So we get 0 equals w squared plus 4w minus 117. Well, let's factor that into two binomials. And as I look at that, I know that w squared has to be w times w, but what are the factors of negative 117? Let's see if we can figure out what they are. We know negative 1 and 117 and 1 and negative 117. But remember, our goal with these factors is to add up to our middle term. And adding these two together does not get us anywhere near 4. So what else goes into 117? Well, the digits add up to 9, and 9 is divisible by 3, so I know 3 goes into 117. So let's try that. 3 goes into 117 39 times. Do those add up to positive 4? No. So let's try some more. Again, the digits add up to 9, so I know 9 goes into it. So let's take 117 divided by 9, and we get 13. And as I look at those, I do have a pair that adds to 4. This pair right here adds up to 4. So to multiply to get our last term, the terms that I want to use are negative 9 and 13. Set each factor equal to 0 gives us w minus 9 equals 0, so w is 9. W plus 13 equals 0. W equals negative 13. It looks like we have two solutions. However, as I look at these solutions, I realize that my width here has to be a positive number. It can't be negative. So our width has to be 9. It can't be negative 13. So our width is 9 inches wide. Okay, last, when we factor trinomials, we can have more than one variable. We're going to look at it the same way we've looked at it before. To get x squared, our first term has to be x times x. To get our last term, the only thing that's different is we also have a y squared in there. So our factors are a way to multiply to get 8y squared. And again, we're just going to list the factors of 8, but each one with a y. For instance, we could have 1y and 8y. We could have 2y and 4y. I'm looking for the pair that adds up to 6 in the middle. 4 and 2 add up to 6, but where does the x come from in here, 6xy? Well, let's see how that works. Our 4 and 2 does add up to our coefficient 6, so let's try it. Let's do plus 2y and plus 4y. Now let's do our check. First, x times x is x squared. Outer is x times 4y, which is 4xy. Now we see where the x comes from. Inner, 2y times x, which is 2xy. And last is 8y squared. Our outer and inner term add up to 6xy as required. So there really wasn't much difference. All I did was have our last term, instead of just a number, it's a number multiplied by the variable y. Let's do another one here. We have m squared minus 5mn minus 24n squared. So again, we're going to have two binomials. To multiply to get m squared, our first term, we have m times m. Our last term, we have to multiply to negative 24n squared. So our factors of negative 24, and when we get in, we'll just put, we have a factor of n here for each one of those to get n squared. But let's see what we need with negative 24. We have negative 1 and 24, 1 and negative 24, negative 2 and 12, 2 and negative 12, negative 3 and 8, 3 and negative 8. There's a lot. We have negative 4 and 6, and 4 and negative 6. Which pair adds up to negative 5? So as we're looking at them, we see this pair adds up to negative 5. So we're going to have plus 3n and minus 8n. Let's do our check. First, m times m is m squared. Outer m times negative 8n is negative 8mn. Inner, positive 3n times m is positive 3mn. And last, negative 24n squared. Again, our middle term adds up to negative 5mn. And that's our lesson on factoring trinomials.